March 12, 1940, Britain is slowly being strangled. Not by bombs falling on London, not by tanks rolling across the countryside, but by something far more insidious. The silent disappearance of ships in the cold, dark waters of the Atlantic Ocean. Every week, another convoy sets out from North American ports, stacked with wheat, oil, medicine, and the raw materials of war. And every week, fewer ships make it back. By the time you're reading this, the numbers are already terrifying. In the first 4 months of 1940, over 250 Allied ships have been sent to the bottom by Germany's silent killers, the U-boats. This isn't just metal and cargo. It's blood, it's families, it's survival. Without these supplies, the island will starve. Factories will shut down. The war effort will collapse from the inside out. At the center of this storm is Admiral Karl Dönitz, commander of Germany's U-boat fleet, a meticulous, calculating man who's mastered the art of the wolf pack. Groups of submarines moving together, hunting together, attacking in the dead of night. When the escorts are asleep or looking the wrong way, when radar is blind and sonar is useless, they strike. Fast, silent, deadly. Prime Minister Winston Churchill would later admit that of all the horrors in the war, Dunkirk, the Blitz, the threat of Nazi invasion, the only thing that really frightened me was the U-boat peril. But as terrifying as the Atlantic has become, the real nightmare is closer to home. November 1939. Just weeks after the war begins, something strange, something unnatural, starts happening in British coastal waters. The destroyer HMS Gypsy is cruising near the mouth of the Thames. This is supposed to be safe water, British water. It's been swept for mines dozens of times. Then, without warning, she explodes. One moment afloat, the next torn in two. No enemy periscope, no torpedo, no visible threat. 3 days later, a merchant ship is hit in the same spot. Then another, and another. Over a dozen vessels lost in Britain's home waters in just weeks. Crews whisper of ghost attacks, ships vanishing without explanation. Veterans who've sailed through storms and U-boat gauntlets now refuse to enter certain ports. The Royal Navy is baffled. These aren't contact mines, nothing their sweepers can detect or disarm. These ships are dying in waters they've sailed safely for years. There's no pattern, no warning, no defense. Then, finally, a break. A German plane is spotted dropping something by parachute into the mudflats near Shoebury-Ness. British bomb disposal moves in as the tide recedes, and what they uncover is bizarre. A mine, yes, but nothing like they've ever seen. No horns, no pressure triggers, no obvious detonation mechanism, just a smooth metal shell lying quietly in the mud, waiting. Lieutenant Commander John Ouvry, a veteran of mine warfare, spends hours carefully dissecting the device. One wrong move, and they'll all be vaporized. But inside is the answer, a magnetic trigger, a new kind of mine, one that doesn't wait to be bumped, one that senses passing ships and detonates based on the magnetic field of the steel hull. Britain isn't just losing ships to U-boats. It's now under siege by invisible weapons, mines triggered by the very essence of the ship itself. The realization is devastating. These mines can't be swept the old-fashioned way. They don't float. They rest on the seabed, unreachable, undetectable, unstoppable. The pressure lands squarely on a man who, by all accounts, has no business being anywhere near the Royal Navy. His name is Charles Goodhue, a Canadian chemist, a scientist, a civilian, a man more comfortable in a laboratory than on a warship. Yet, by a twist of fate and Britain's desperation for any idea that might help, he's been drafted into the war effort under a peculiar new department, the Department of Miscellaneous Weapons Development. The job of this department? Handle the ideas too weird for anyone else. And Goodeve has an idea that even the most desperate admirals think is mad. He proposes wrapping entire ships in copper cable. Not just any cable, thousands of feet of it. He wants to run an electrical current through this cable to generate a field that cancels out the ship's natural magnetism. The hull's magnetic signature would become nearly invisible to the mines. In theory, the ship would still be there, but magnetically, it would vanish. He calls it degaussing, from Gauss, the unit of magnetic measurement. And while it sounds like something out of a science fiction magazine, Goodeve insists it can be done. The math works. The physics is solid. But convincing the Royal Navy? That's another story. Admirals scoff. Some laugh. One even asks if Goodeve is drunk. But Churchill's Britain doesn't have the luxury of pride anymore. Too many ships are dying. Too many sailors are lost. The idea is approved. Not because it sounds sane, but because nothing else is working. And so begins one of the most unlikely engineering campaigns in British history. Turning warships into floating electromagnets, battling physics itself to save a starving nation. They started small, out of necessity, not caution. In January 1940, deep in the fog-laced docks of Portsmouth, Goodeve and a hastily assembled team of naval engineers, physicists, and war-hardened electricians took their first swing at the impossible. Their test subject, HMS Borealis, a minor minesweeper with a reputation for breaking down at the worst possible moments. Hardly a shining jewel of the fleet, but expendable. And, more importantly, available. They measured her magnetic signature from every angle, using delicate magnetometers most dockyard workers had never even seen before. The readings were grim. Her hull glowed like a beacon to magnetic mines, like a steel siren song to death. Then the real work began. They wrapped her in copper wire, loop after loop, all calculated to the centimeter. The cable was thick as a man's thumb, stiff, uncooperative. Goodeve paced the dry dock like a man possessed, scribbling equations on scraps of oil-stained paper, adjusting the placement with obsessive detail. It took 3 days, and several bloody hands later, the ship looked more like some radioactive experiment than a vessel of war. They powered up the generator. The cables hummed, and then nothing happened. Not silence exactly, but no explosion, no smoke, no failure. They ran the tests again. The magnetometers showed a drop in signature by over 90%. On paper, the Borealis had disappeared, at least magnetically. Word of the success shot through the dockyards like a depth charge. But where others saw victory, Goodeve saw a logistical nightmare. Borealis was a baby compared to the real fleet. Britain had over 9,000 merchant vessels, not to mention battleships, destroyers, tankers, and trawlers, each one with a unique magnetic signature, depending on where it was built, how it was built, and which way it was facing during construction. Some ships were so old they had already been magnetized for decades. Others had inconsistent welding patterns that made their fields impossible to model with simple formulas. To degauss every ship, they'd have to measure each one individually, calculate a custom wiring pattern, source the copper, train the crews, and install the system. Fast, but copper was already in short supply, and Britain was hoarding every inch of it for aircraft wiring and radio equipment. Convincing the Ministry of Supply to hand over tons of it for an unproven electromagnetic armor? That required more than just calculations. Goodeve argued not like a scientist, but like a maniac with nothing left to lose. He brought numbers, brutal ones. If we don't degauss, he warned, we lose 100 ships a month. That's starvation by October. That got attention. So the Admiralty gave him what he asked for, and more. They handed him control, over a fleet-wide program, over copper shipments, over dockyard schedules. It was as if someone handed a university professor the keys to the war effort. Work began around the clock. Portsmouth, Liverpool, Belfast, Glasgow. The ports lit up like refineries, buzzing with activity day and night. Copper cable arrived on rail cars. Workers wrapped it around hulls in rain and air raids. Men with no naval experience, university physics students, women from code-breaking offices. Retired electricians pulled out of quiet countryside homes now found themselves crawling along the rusted spines of oil tankers in blackout conditions, threading cable while Luftwaffe bombers howled overhead. Some died doing it, but the work never stopped. Meanwhile, the Germans were watching. By late March 1940, something strange began happening on the Kriegsmarine's war charts. Mines were failing to detonate. Convoys were passing through previously lethal areas untouched. At first, they assumed a fault in the mines themselves. Defects, sabotage. But by April, they knew something had changed. Their weapon, the magnetic mine, was going blind. And that's when the Germans started adapting. By May, they began adding acoustic triggers to the mines. Sensors that would detect the rhythm of propeller blades, or pressure-sensitive switches that needed both the magnetic field and the shock wave of a ship overhead to detonate. It was a deadly chess match, each side pushing science further than war had ever demanded before. Back in Britain, Goodeve's team, now numbering over 3,000 engineers, dock workers, and technicians, had their own response. They developed wiping stations, shore-based electromagnetic fields that temporarily scrubbed a ship's magnetic signature as it passed by. It wasn't permanent, but it could be done in minutes. A ship would steam past a coastal gantry, get zapped by high-voltage magnets, and emerge invisible for a few weeks. It wasn't perfect, but it bought them time. By June 1940, nearly 4,000 ships had been degaussed. The numbers were changing. In just 3 months, mine-related sinkings in British waters dropped from 115 to fewer than 20. Dropped from 115 to fewer than 20. Goodeve's mad idea was becoming doctrine. But outside the harbors, the sea still ran red. The U-boats had not gone anywhere. If anything, they were growing bolder, hungrier, and now more coordinated than ever. And with the fall of France, German submarines were suddenly 400 miles closer to British shipping lanes. The Wolfpacks could hunt deeper and longer, and their torpedoes didn't care if a ship was degaussed or not. The next chapter of survival would require something far more terrifying than cables and math. By July 1940, the docks no longer slept. In Liverpool, men worked by torchlight with copper grease staining their fingers and black soot caked into their lungs. In Glasgow, teenage boys too young to hold rifles climbed scaffold rigs to loop electromagnetic cables around corroded hulls. In Belfast, women scribbled coil pattern calculations faster than the crews could install them. Working from Goodeve's ever-growing manual of magnetic signatures by vessel. Class! The numbers were growing. Fast, more than 5,000 ships had been, degaussed by the end of summer. But even as British ports became sanctuaries from magnetic death, the open ocean remained a slaughterhouse. The German U-boats, now operating from the captured French ports of Brest, Lorient, and Saint-Nazaire, no longer had to sneak around Spain to reach the Atlantic. They just slipped out under cover of night and into the convoy lanes like wolves emerging from a new forest. Convoy SC-7 was supposed to be safe. It left Sydney, Nova Scotia in October 1940 with 35 merchant ships, many of them degaussed, some carrying desperately needed wheat and ammunition. One carried blankets, another diesel fuel. All of it needed yesterday, but by the time they reached mid-Atlantic, their lone escort, a sloop, was overwhelmed. Dönitz had committed a full wolf pack. The U-boats struck like coordinated ghosts, surfacing under the cover of a moonless night, launching torpedo after torpedo into slow-moving hulls that had no radar, no long-range sonar, and no hope. 20 ships were lost. Over 140,000 tons of cargo. Hundreds of lives. Degaussing had done nothing to stop it. Because magnetism didn't matter here. Out here, it was speed, silence, and the sharpened teeth of Donitz's submarines. It was a punch to the gut back in Britain. Goodeve's team was told, "You've bought us time. Now we need more." But Goodeve didn't see it that way. In a letter to a colleague at Cambridge, he wrote bluntly, "We're not just fighting submarines anymore. We're fighting ignorance, the refusal to see science as strategy." That same month, Goodeve started something no one expected. He proposed turning every ship into a sensor, not just protecting vessels from mines, but using their magnetic readings to track anomalies in the water. If a ship sailed past a stretch of ocean and suddenly its field spiked, it could mean a U-boat nearby, its own steel hull disturbing the ambient magnetic field. He called it reverse detection. But the Admiralty laughed. Again, your last miracle was tolerable, because it made ships vanish, one Commodore reportedly told him. Now you want ships to see? But something else happened around this time, quiet, unofficial, and deeply British. In Southampton, a destroyer captain named Lieutenant Commander Ronan Hale made a decision, one that wasn't in the manuals. His ship, HMS Grey Moor, had been degaussed weeks earlier. But Hale, paranoid and fiercely independent, added a second coil and secretly ran it on a fluctuating current, not to stay invisible, but to see what pulsed back. A few nights into patrol, his magnetometers went mad off the coast of Ireland. No mines, no enemy fire. But the readings were off the charts, so he dropped a pattern of depth charges on instinct. Seconds later, a U-boat surfaced, burning. He killed it, with a magnetic hunch, a ship acting like a sensor, just as Goodeve envisioned. And Goodev, hearing about it through the engineer's rumor mill, exploded with new energy. He rushed to Portsmouth with a new idea. Active Degaussing Detection Systems, ADDS. He didn't just want ships to be invisible. He wanted them to be aware. Again, they laughed. Again, he started building anyway. But something else changed that winter. Morale. Merchant sailors, once terrified to dock in ports like Cardiff or Liverpool, once refusing to sail through estuaries that had claimed their friends, started requesting degaussed ships. They would wait longer for a degaussed hull. They'd sleep better on one, because even though they still faced torpedoes in open water, at least harbor wasn't a graveyard anymore. Degaussing, once seen as fringe science, was now a shield, a comfort blanket in a war that offered precious few comforts. By early 1941, the Admiralty shifted tone. They no longer treated Goodeve's team as the cranks from the Department of Miscellaneous Weapons. They were given a seat at the operations table. Goodeve's office moved inside the War Office. His team's notes began being classified. His staff doubled, then tripled. He was no longer professor. He was now Commander Goodeve, a naval officer in rank if not in demeanor. And with that came one final twist, a rumor. The Germans were adapting. New. Mines were being deployed with combined triggers, magnetic and acoustic. Some could even detect pressure changes from a ship's bow wave. Goodeve's degaussing might no longer be enough, but Goodeve was already ahead of them. He had a new idea, a mad one, and this time it wasn't about hiding. It was about fooling the mine into firing too early, far from the ship. It was time to turn degaussing into a weapon. By spring of 1941, Charles Goodeve no longer just wanted to defend ships. He wanted to deceive the enemy's weapons. His next idea would push the line between physics and illusion. If magnetic mines could be fooled into not seeing a ship, Could they also be tricked into seeing a ship that wasn't really there? What he envisioned was more than just protection, it was magnetic warfare. The theory was seductive in its simplicity. Magnetic minds didn't think, they didn't choose, they reacted. Cold, automatic. Triggered only when they sensed a magnetic signature crossing a threshold. So, what if you gave them that threshold on purpose, but from a fake source, and at a safe distance? The answer was a device codenamed Double L. Picture two steel pipes, laid out in an L shape, slung beneath a small boat or motor launch. Wrapped tightly with thick copper coils and pulsing with controlled current, this frame would emit a false magnetic signature, one strong enough to mimic a destroyer or cargo ship. When towed slowly past suspected minefields, it would trick the mines into detonating early, in empty water. No damage, no casualties, just a wasted explosion, and a safe lane carved open. The Admiralty approved trials within a week. The first live test happened off Harwich, in shallow coastal waters laced with known magnetic mines. The vessel, a converted fishing trawler, stripped to the bone, with a single volunteer crew and no promise of survival. As the Double L frame dipped into the water, the crew fell into silence. Not fear. They'd gone past that weeks ago, but resigned tension. Every mine they passed might be their last. Then, at 05:31 hours, the sea erupted. One detonation, then another. Bursts of water and iron hurled 50 feet into the air, far ahead of the towing vessel. But the ship itself remained untouched. As the smoke cleared, the test crew radioed back a message no one expected. "She's done her job. Lane's clear. No damage." Just like that, Double L was greenlit for full deployment. Goodeve had created a weaponized illusion, one that killed without ever having to sink anything real. But even as Goodeve's electromagnetic games saved ships in coastal waters, the Atlantic itself was still a butcher's alley. U-boats, now numbering over 100, were coordinating with deadly precision. Entire convoys were disappearing. Just weeks after the success of Double L, Convoy HX-1-12 sailed straight into a trap off Iceland. Dönitz had positioned a dozen U-boats, relaying signals by encrypted code. By the time the battle ended, 6 merchant ships lay at the bottom, and 2 of the Royal Navy's most experienced destroyers, HMS Gurkha and HMS Exmoor, were gone. Hundreds dead, supplies lost forever. But the real loss that night wasn't steel or cargo. It was a myth. The myth that technology alone would save them. Back in London, Goodeve stared at the telegrams in disbelief. He was exhausted, pale, his notebooks overflowing with scribbled circuit diagrams and degaussing readings from across the empire. The degaussing program had neutralized the magnetic mine, yes, but torpedoes didn't care about cable coils. The sea demanded more. It demanded everything, so Goodeve pivoted again, this time not toward ships, but toward aircraft. If the enemy hunted below the waves, then protection would have to come from above them. In a midnight meeting under blackout conditions, Goodeve pitched a radical expansion of his magnetic deception work. What if aircraft could simulate convoy signatures from the sky? Imagine a bomber flying low, trailing cables or carrying tuned emitters, radiating false magnetic fields that mimicked a cluster of ships. The U-boats, sensing what they believed to be rich, fat targets, would move in, only to be caught by patrolling destroyers, or worse, attacked from the air. The Germans called it Operation Paukenschlag. Drumbeat. January 1942. As snow blanketed, Britain and Goodeve's team worked through blackout nights installing magnetic shields under searchlight and siren. Germany opened a new front in the Atlantic War, one that would shock the Americans out of their slumber. This time, The U-boats were coming for New York. The fall of France had already given the Kriegsmarine deep-water ports, shortening their route to the Atlantic. But now, Dönitz, confident, bloodthirsty, and high on the U-boat arm's success, sent his packs west, right into American coastal waters. The Americans, unprepared and unwilling to believe war had reached their shores, left their cities lit up at night, like targets on a rifle range. Cargo ships sailed up and down the eastern seaboard, silhouetted against the neon glow of Times Square and Atlantic City. No convoys, no escorts, no blackout orders. It was like shooting fish in a barrel. In the first 2 months alone, over 100 ships were sunk within sight of American beaches. Oil tankers exploded just offshore. Survivors washed up on sand dunes. Debris floated into harbors. Children playing on beaches found life jackets. And just like that, the Atlantic War doubled in size. Back in London, Charles Goodeve stared at the naval reports from American shores with cold fury. He had warned them. Degaussing plans had been offered to American naval attachés as early as late 1940. Some were accepted. Most were ignored. The U.S. Navy was still drunk on peacetime arrogance. They didn't believe in British panic science, as one admiral had once sneered. Now, the panic was theirs. By February, Washington was begging for help. And Goodeve, ever the pragmatist, didn't hesitate. He ordered all technical manuals, design schematics, and magnetic measurement data bundled and shipped directly to the U.S. Office of Naval Research. No strings, no patents, just science for survival. But Goodeve wasn't just exporting blueprints. He sent people. Dozens of his best technicians, engineers, physicists, even cable riggers, boarded troop ships bound for Norfolk, Boston, Halifax. They wore civilian clothes, carried notebooks and voltmeters. None had ever held a gun. But what they brought was more powerful than firepower. They brought invisibility. In Halifax, Canadian destroyers began hosting American ship crews for crash training in magnetic field suppression. In Brooklyn, American dock workers were taught how to wrap hulls with degaussing cable under the watchful eyes of Goodeve's former students. In New Orleans, the first American-built Liberty ships were being fitted with factory-installed degaussing coils, a concept Goodeve had fought tooth and nail for months earlier in Britain, only now realized across the Atlantic. And while the Americans scrambled to catch up, Goodeve turned back toward home, and to a threat even closer than torpedoes. It started with a whisper, then a report, then 2 more. Ships were once again exploding in British estuaries, in waters that had been degaussed, swept, and reswept. Not by torpedoes, not by mines, but by something no one could find. A new type of mine. Smaller, meaner, smarter. The Germans had developed what Goodeve feared most, a combined trigger mine. Magnetic plus, acoustic plus, pressure. They called it the oyster. The pressure switch waited for the bow wave. The acoustic sensor listened for propellers. The magnetic detector confirmed the kill. A triple-check system. Only when all 3 lined up did it explode. Deadly accurate and nearly impossible to fool. Traditional degaussing? Useless? Magnetic noise fields? Ineffective. Even Goodeve's trusted double L minesweepers couldn't fool it. The oyster demanded a new kind of trickery. A perfect simulation of a real ship, passing overhead at full speed with the right sound, the right pressure wake, and the right magnetic field, all at once. It was like trying to seduce death with a puppet. And Goodeve accepted the challenge. He gathered his most brilliant minds, not military men, but the ones who understood chaos, deception, and behavior. Wave engineers, acoustic physicists, even an experimental musician who had built custom sonar tone generators for the Royal Navy. Together, they designed something radical. They called it The ghost ship. Not a vessel, but a portable simulation platform, a frame built from lightweight alloy, towed beneath the waves, fitted with a rotating propeller noise emulator, a pressurized ballast tank to mimic a displacement wake, and a modular magnetic coil generator. It could be programmed to simulate any class of ship, from a tanker to a destroyer to a fishing trawler, using tuned electromagnetic pulses, underwater acoustic drivers, and ballast-controlled wake effects. It was madness on a winch. It was Goodeve's masterpiece. The first test came on a fog-soaked morning off the coast of Firth of Clyde. The ghost ship was deployed by the minesweeper HMS Calliope, slowly dragged across a suspected oyster minefield. The sea was silent. Nothing moved. Until it did. Boom, then another and another. 7 mines detonated in less than 6 minutes. Calliope had to tow the frame back in tatters, but the crew cheered. Some wept. Goodeve just lit a cigarette and muttered, "It works. The ghost bleeds." By the summer of 1942, ghost ship sweeps were clearing new minefields almost weekly. Oyster mines, once a death sentence, now had a counter. Another invisible threat, defanged by a man with chalk-covered fingers and no medals. But by then, Goodeve's name had started to spread. Not in the press, not in parades, but in whispers among captains and convoy commanders. If your ship's still floating, thank the Ghostmaker. Yet, Goodeve wasn't finished. Not by a long shot. There was one last invisible threat. One no magnetic coil could defeat, no wire could shield. A threat made of silence, calculation, and German code. By late 1942, the invisible war had shifted yet again. The convoys were no longer being slaughtered at the same terrifying rate. Goodeve's degaussing network stretched from Belfast to Bombay, protecting more than 90% of all Allied vessels from magnetic mines. Ghost ships now danced across seafloors, tricking oyster mines into wasting their fury on water. Magnetic torpedoes had met their match in noise-field shielding. But the sea had never just been about weapons. It was about information. And the Germans still had a devastating advantage. They knew where the convoys were before the Royal Navy did, because buried deep in Berlin's high command was B-Dienst, the German naval code-breaking unit. And they were reading the Allies' convoy orders in near real time. Every sailing schedule, every escort assignment, every route adjustment. To the wolf packs, it was like reading a battle map before the pieces were even on the board. No matter how many U-boats were sunk, how many mines swept, how many ships degaussed, the enemy still struck first. And now, with more U-boats than ever, Dönitz unleashed new tactics. Line patrols, where submarines stretched across hundreds of miles like a net, waiting for their prey. Convoy, on 127, was the first to feel it. 33 merchant ships, 6 escorts, 5 of them degaussed, 2 equipped with magnetic field distortion systems. They sailed from Liverpool toward New York in September 1942. Somewhere off Greenland, 11 U-boats converged. By dawn, 7 ships were gone. Again, it was clear. Goodeve's machines could protect the hull. But nothing could protect a ship from being found. The Admiralty turned desperate eyes toward Goodeve. We need more. We need something new. But Goodeve had already begun. 6 weeks earlier, in a damp basement in Portsmouth, behind a door marked simply Black Room, Goodeve had started working with a group of signal analysts and mathematicians from Bletchley Park. Not Enigma specialists, but radio men, frequency men, who had noticed something strange. Some U-boats, after attacking convoys, disappeared completely. Not sunk, not destroyed, just gone. No intercepts, no sightings, no evidence of movement. Goodeve thought like a scientist. But more importantly, he thought like a magician. He looked for what wasn't there. He asked a dangerous question. What if they aren't just hunting us invisibly, but hiding themselves magnetically? It was a theory no one wanted to believe, that German submarines had developed a counter-degaussing system, one that reduced their magnetic profile to nearly zero. That's why Royal Navy ships with magnetic detection buoys were missing them entirely. It would mean Britain's sonar arrays were half-blind, and if true, it meant Dönitz's crews had learned from Goodeve and were now copying his own science against him. Goodeve's response? He invented a trap. He called it the Iron Curtain. No, not the Cold War metaphor. The real one. A curtain of magnetic detectors, towed underwater by trawlers in long arcs, covering vast sections of open ocean like invisible nets. These weren't just passive buoys. They pulsed. They challenged the ocean. And when something metal moved, even faintly, even a ghost signal from a magnetically cloaked U-boat, it rippled across the sensors. It was an insane idea. Drag dozens of expensive detection frames behind vulnerable ships just to look for a whisper. But it worked. The first test, off Rockall Bank, lasted 12 hours. Nothing. Then a ping. A weak ripple. A pattern inconsistent with natural flow. The escorts dropped depth charges in a spiral. Seconds later, oil bubbled to the surface. Then black debris. The hull of a German Type 9 submarine surfaced briefly. Cracked, broken, and silent. Captured radio logs confirmed it had been one of Dönitz's stealth patrols. Goodeve's Iron Curtain had torn open the sea and caught a shadow. After that, the program scaled fast. Too fast. Program scaled fast. Too fast. Iron Curtain frames were sent to Canada, to Iceland, to North Africa. It became the first active magnetic anti-submarine net in history. No longer were magnetic systems just defense. They were now weapons of detection and ambush. Dönitz, for the first time, saw his silence become a liability. But Goodeve wasn't done innovating. In that same basement in Portsmouth, beneath flickering gas lamps and the smell of warm metal, he was building something no one dared suggest out loud. A system that could detect a U-boat before it fired, not from its periscope, not from its torpedo launch, but from the faint magnetic disturbance it created simply by being there. He called it blind sight. Because that's what the Allies needed now. Not just eyes on the water, but a sense of the sea's mood. A way to feel the threat. But while he built that, convoys continued to vanish. The U-boat numbers were still growing. Mines were still evolving. Torpedoes were getting faster, quieter, more intelligent, and Operation Torch, the invasion of North Africa, was only weeks away. Goodeve knew. One wrong turn now, one magnetic oversight, and thousands of men could die before they reached the beach. The final and most complex magnetic deception of the war was about to begin. November 1942, Operation Torch was the largest Allied amphibious assault to date, 3 task forces, nearly 850 ships, over 100,000 men, all converging on the coasts of Algeria and Morocco. If the landings failed, the Nazis would tighten their grip on North Africa. The Mediterranean would remain closed. The war in Europe could drag on for years. But Charles Goodeve saw something different. He didn't see ships. He saw targets, hundreds of hulls, thick with steel, all broadcasting their magnetic signatures like lighthouses to the enemy. It didn't matter how secret the landing was. If even one magnetic mine lay in the harbor approaches of Oran, Algiers, or Casablanca, entire troop transports could vanish beneath the waves before the invasion even began. So once again, Goodeve was called, not for glory, not for speeches, but because someone whispered the truth. If we don't protect the fleet, it's over before it begins. He arrived in Gibraltar aboard a slow freighter disguised as a banana boat. No uniform, no guards, just crates of copper coil, magnetometers, and a battered leather satchel bursting with calculations. In the days leading up to Torch, he slept 3 hours total. British and American naval officers argued over tactics, timing, and maps. Goodeve paced the dry docks of Gibraltar like a man possessed. He checked every harbor cable, verified every wiping station generator, reran magnetic field interference tests under cover of night. He knew the Germans had expected a landing soon, and he knew they had laid something special, a mine, but not just any mine. One designed for amphibious invasion. Goodeve had intercepted chatter, radio, logs from U-boat crews and Luftwaffe aerial reports. He pieced it together. The Germans had dropped what his team codenamed the Judas device. It didn't trigger on the first ship. It waited. 5, 10, maybe 20 vessels would pass safely. Then, boom. A single, delayed blast in the middle of a tightly packed invasion fleet. The explosion wouldn't just sink one ship. It would start a chain reaction. Mass panic, troop delays, landing craft disorganized. An entire front unraveled before the first shot was fired. There was no time to find every Judas mine. The minefields were too new, too smart, too well hidden. So Goodeve did what no naval officer would dare suggest. He proposed baiting them, a decoy, not with hulls, but with magnetism. The night before the landings, under strict radio silence, Goodeve's crew deployed 3 ghost ship platforms, modified for Torch. They were disguised magnetically as troop transports, complete with field-tuned props and variable noise generators. Each one was towed slowly into the 3 main harbor approaches and released. Then they drifted, riding the current into shallow, mine-laced waters. One exploded off Algiers. The shockwave was felt miles away. Another triggered 2 blasts near Oran, Judas mines, set to kill only after the 6th ship passed. The third, it triggered nothing, and that told Goodeve everything. Casablanca was clean. When the real fleets arrived hours later, escorted by degaussed destroyers and magnetically cloaked minesweepers, they found what should have been a graveyard, eerily quiet, no mines, no explosions, no magnetic deaths. The invasion was a success. North Africa became the first domino to fall in Hitler's southern flank. And Goodeve? He disappeared into the background. Again. By early 1943, his name was rarely mentioned in public dispatches. He never held a field command. He never asked for one. But every Allied ship, every convoy, every troop carrier that crossed from New York to Liverpool, from Cairo to Malta, carried his silent protection. His degaussing program had saved tens of thousands of lives. His magnetic illusions had neutralized Germany's wonder weapons. His theories became standard naval doctrine in every Allied navy, but there were no medals waiting, no fanfare. Just a final report, stamped top secret, that ended with a single line. Dr. Goodeve's work rendered the enemy's magnetic mines operationally ineffective across all theaters. After the war, Charles Goodeve returned to science. He was knighted quietly, appointed to advisory roles, and helped rebuild Britain's technological infrastructure. But he never boasted, never toured, never even published a memoir. Because for Goodeve, the war had never been about glory. It had been about understanding the sea's invisible war, and winning it with a little wire, a lot of math, and an idea everyone thought was mad. And somewhere beneath the waves, in rusting German mine casings long since buried by sand and time, tiny magnetic sensors still wait, listening for ships that will never come because they can't hear them anymore. Charles Goodhave made sure of that. Goodhave made sure of that.